Charging method of increasing the inlet air density called supercharging is usually employed to increase the power output of the engine. Supplying air at a pressure higher than the pressure at which the engine naturally aspirates air from the atmosphere will increase the density, hence power output. Pressure boosting device is called supercharger. Supercharger comprises of a compressor, positive displacement type. Compressor provides a denser charge to the engine so that a greater mass of air is inducted inside the engine and a more amount of fuel can be burned. The compressor derives its power from the engine crankshaft. When the engine is normally aspirated, it relies on atmospheric pressure to push the air into the manifold and into the combustion chambers. Due to internal flow restriction along the air path, the normally aspirated cylinder is never able to completely draw in full charge of air-fuel mixture. Objectives of supercharging: to increase the engine output without changing its weight and size, compensation for the loss of power due to altitude aircraft engines. Effects of supercharging: better mixing of air and fuel due to increased turbulence, higher temperature at the end of the compression process with the help in quick vaporization of fuel. The increased temperature is likely to increase the knocking tendency in SI engines and decreases the chance of knocking in CI engines. Supercharging system will absorb a fraction of power produced by the engine, and therefore some of the gain in power output due to supercharging is load mechanical efficiency is affected. For supercharging, the following engine modification required: cylinder head and valve train preparation. For higher boost application, consider a 3-angle street type valve grind to promote better cooling. With the additional combustion temperatures normally generated in a supercharged engine, the wider valve seats will provide better cooling of the valves, and the 3-valve angle will grind provide better sealing of the valves. When any port work is being done due to your cylinder heads, most of the effort should be directed to the exhaust ports. The supercharger will overcome most minor restrictions on the intake side of the cylinder head. The use of boring head gaskets requires receiver grooves in the heads and block milled by a component machine saw. Carburetor and induction considerations: at full throttle, blow-down engine can require 50% more air than an unblown engine, and a result needs a larger carburetor in order to make maximum power and boost. If your blow-down engine is primarily driven on the street at moderate engine speed under 4000 rpm, you won't need a larger carburetor. Typically, the carburetors will need to be enriched by 5 to 10% on the primaries and 10 to 20% on the secondaries. The ideal mixer screws may need to be enriched by 1 or 2 turns. In either case, the carburetors need not to be jetted properly to prevent a lean condition. A lean condition can lead to overheating and detonation. For initial startup, it is better to have slightly rich condition to help prevent the engine from overheating. After initial startup, check the spark plugs for proper reading and adjust the carburetors accordingly. Camshaft selection for the supercharger. A supercharger can overcome inadequacies in a stock cam up to about 4500 to 5000 rpm. Typically find the performance with a blower will not be significantly enhanced below these speeds with the cam change. However, for optimum performance at high RPMs, a more aggressive camshaft will provide substantial power increases. For best performance with blower, you should look for a cam that has higher lift and longer duration on the exhaust side. Street performance with a blow engines is usually best with a cam that is ground with a 112 to 114 degree lobe separation. With the use of an alternate market camshaft, follow the camshaft manufacturer recommendation for valve springs. Ignition system settings for superchargers. Blown engines make great power in the low and mid RPM range. That means most late model OEM electronic ignition systems have the capability of working well with a supercharger and will be fine if you keep your driving under 5500 rpm. Some distributors will come with a computer controlled advanced curve and timing may not be compatible with a supercharger because of the preset timing and sensors they require. However, any of the aftermarket high performance standard or electronic distributors should function well when properly calibrated.